There we go. Yeah, I guess I don't need that thing. Oh, I can't close it. That's interesting. Anyways, yeah, I was just adding a tweet here because this Excalibur thing is really working out for us at Code Sandbox. So I thought I would add the documentation for people to actually set it up by themselves. And of course, we'll continue working on this. Just add the docs on so you can deploy your own persistent Excalibur, share with colleagues on the same Google domain or your personal email, and with live sync. And we are using it and will improve. Let me know. Does it work? Or personal. Okay, just add the docs on Excalibur file so you can deploy your own persistent Excalibur, share with colleagues on the same Google domain or personal email, and with live sync. We are using this at Code Sandbox and we'll keep improving it as we use it. Does it work? Cool. Let's tweet that and let's get into what we're actually working on. Yeah, and I wanted to give this to James Long. You to try following the steps. J Longster. See if it works. Okay, cool. Yes, let's get back to it. So we were working on this application and we're following the React States architecture approach where we have drawn up the flow of the application, and then we are identifying the environment interface. So what does this application need from the environment to operate? And we don't care how, like we're going to connect it to Firebase, but we don't really care about that now. We're just defining an environment interface that's best suited for consumption for this app. And by the way, I'm on baby patrol right now. Our oldest got sick yesterday, so they're at home, so I have to help out a little bit. So I might suddenly drop off, but I'll let you know, of course. And yes, so where are we? Okay, so we have a couple of environment effects here. Where we, let's see. Yeah, maybe we should create like the environment provider. So we're going to environment provider, and this environment provider takes an environment, and that environment needs to be of this interface where we say auth will be the auth, and we have storage which will be the storage coming from storage. And what we're going to do, we're going to say that yes, this is the environment, and then we also have children, and we're going to type that as children is of course React node, and then environment will actually be a partial of the environment, And the reason we do a partial is because we're going to use it for testing as well. And we don't want to mock everything. Like, we don't necessarily need the whole environment or mock the whole environment to do a test. So that's why we have a partial there. And basically what we're gonna do here is we're going to create a context for it. Create context from React and as environment. And we're going to export use environment, use context, and then basically we're just going to render this out. Context provider value would now be the environment, and then we have the children. Yes, so this is where the typing like doesn't really help us, because when we consume the environment in the actual app, we don't want it to be partial, right? But when we pass it in as a prop, we do want it to be a partial. So we're going to just override this, and this is, again, it's for testing. It just simplifies the testing. Yes, so now we have like exposed environment, and we have the auth interface, which is like sign in and authenticate, and we were working on our storage where we were adding archive a task and set weak task activity. Set task like, is it set weak task activity or set task? Yeah, it's like we're setting it on the week, right? Yeah, I think that's good. And here we have our proof of concept environment where we're actually implementing this interface, and we're faking it all the way. So what we're going to do later, we're going to add a test environment where we actually create mocks so that we can effectively test this. And then we'll also add a browser environment where we actually have the implementation using Firebase. Yes, so let's finish implementing our proof of concept environment where we need to be able to archive a task, and that takes an ID. And what does it return? Nothing. Okay, so we'll just do async. We'll just say that that always works. Yeah, so what's interesting about this is that what we haven't talked about is the subscriptions. So we might need some more logic here. So for example, when we archive a task, that should really update the tasks. So we'll check that. Yes, and then we have set grocery shop count. So we need the ID and the shop count. Yeah, and this is also like, do we have like increment grocery shop count? Or do we actually set it? Like, it's extremely unlikely that two people are changing the count of a grocery at the same time. So like there's two, like we can run a transaction that is called like increment, and then it takes the existing value and does like +1. But again, I think it's probably better to do like we're just debouncing when you tap it, and then we'll kind of send the count. And there is a risk that someone else is also changing the count. So I'm setting it to 1, and then like my girlfriend is setting it to 2, and then one of us will win. And so if I'm the last one sending it, and my girlfriend sees that it's at 2, I'm sending 1, and suddenly it's 1 on her end, and that's confusing, right? But it's like it won't really happen in practice. So the question is, should we be very correct about this, or should we just make sane decisions? Because it's way simpler to just set the grocery shop count. And it's like if we do increment, then we kind of have to send that data to the server every time. And then we have the issue where we're sending it to the server. You might get updates from the server in the meantime because it's waiting for the transaction. And like, I guess you'll have like an eventual consistency there. But yeah, it just gets more complicated because you need to do a transaction, and you have to think about, you might get intermediate updates from another person. Yeah. Like, I just can't decide if we should dive into that complexity or we should just make it simple. Yeah, no, I think we'll make it simple. And did this, yeah, this returns a grocery. So we'll have to say, okay, and then we'll have to insert. Oh, why do I keep getting this signature wrong? So we have the ID already, we have the shop count. So now we have to use, oh, interesting. I'm storing this as an array. But I think for this proof of concept, we're going to need to do a few lookups. So we should store this as a map instead. Yeah. Or should I just find it? Okay, we'll do that for now. That's good enough. It's let's see. We'll do this, and we'll do. Oops. Is this right? No. Oh, is that right? Oh, parentheses. Okay, so we're returning. Okay. And then we have, that's the end of that one. Yeah, this should be good. Okay, so let's just find the existing grocery. Would be groceries find grocery.id equals the ID we pass in. We're just going to say that we always have it because it might be undefined, right? But we don't care about that. So we'll do this, and then we'll just add the shop count to it. And then we have set week task activity, which also returns a result. Am I doing this wrong? I am doing this wrong. Am I missing a parenthesis? Should this be okay? No, that's definitely wrong. Oh, I'm missing this one. Okay, cool. There we go. Okay, so we're going to set the week task activity. It has an ID and week task activity. And that is a week task activity. How did that look like? I can't remember. Oh yeah, it's just an array, right? So we want to set that, and we have the week ID. I think we need some more information on these interfaces. Like, we have to know which family it is. Like, we can do this thing where we configure the storage with the family ID, and then it knows what family ID to use from the inside, which is kind of more, in one way, more consistent, because you can't like update multiple families, so it's a little bit weird that you have to pass in the family ID, but I think we're gonna do that. So maybe we should just update that right away. Yeah, let's do that. So to get the groceries, we actually need the family ID. And to get the tasks, we also need a family ID. And to add a grocery, we need a family ID. Oops. String. To delete a grocery, we need a family ID. To get a family, yeah, of course we need a family ID. And to set the grocery shop count, we also need a family ID. And to archive a task, we need a family ID. And to set the, let's see. So let's update these. Let's just, well, I guess we don't need to deal with the family ID there. We can just do this. Delete grocery, we have to do this. And to get a family, we don't need to archive the task, because I'm getting an error here, right? Yeah. Oh, yeah, exactly. Family ID. And then here we also have family ID. Well, we don't care about it. Cool. Yeah, it's interesting. Like, how do you, like, because what we can do, you know what we're going to do? We're going to try something. Let's remove this. Sorry. I want to try some composition stuff. And let's remove family ID from the thing here. So the way we're going to do this, we're going to, just to try it, is that we're going to, let's see, maybe I can just write it down here. We're going to, so when this application loads up, it's going to use the auth feature. So that's like the top thing. And then it's going to, yeah, how are we going to do this? Because we want to put it into a loading state, but we don't have, yeah, this is really interesting. Okay, just to, oh wait, this won't work. No, this won't work. I'm just thinking about, like, currently we're putting all the environment effects into one provider, but sometimes part of the environment requires some state. Like in this case, we need, for the storage to make sense, we want to be authenticated. But currently there's no real way to do that. Should we just do this? It's like, because the thing is, like, I'm not settled on this, because now the storage implementation is like, it has state in, like, the interface itself is pure. It doesn't have any like internal state, like the interface itself, like Firebase. When we're using Firebase and stuff, of course that has internal state, but not like the interface itself. But if we were to introduce like set family ID, which we can do, and then we don't have to pass in that on all the other things, that is kept as an internal state. And that is perfectly okay, because we can throw an error if that family ID isn't present, and it just simplifies the rest of the interface. but now we've created this like stateful thing, and we're doing this at Code Sandbox as well, because you have a JVT and we have an environment effect called API, and that might or might not have a JVT. So we do that with interface method, which set the JVT. And then whenever you make a request, if it has a JVT, it will add that to the as an HTTP header. And that's a good way to deal with it, I think, because then you don't have to pass the JVT on every single interface. It's rather a configuration. Yeah, I guess it's like a cost benefit thing. It's not, none of the solutions are like pure gold. It's and here it's more of a principle. Like ideally I don't want to have any internal state in the interface itself. But I'm willing to let go of that principle to simplify the interface itself, right? The thing is that if someone were to consume this, it's not obvious that you have to call this before the rest of the interface works. So it doesn't feel quite right. What I could do instead though is that I could avoid having every single effect at the top level. I could rather have, so this is the one approach where you have like auth and storage. But what we can do instead is that we have auth, like an auth effect. And then we would actually how would we do this? So we would have a storage effect. Like this doesn't really represent how it would actually work. Yeah, because the tricky thing is that we do want to this is so interesting. Like if we aren't allowed to do anything until we have signed in, it means that if you look at this overview, like we are going to allow you to actually open something. Like we want to allow you to do this. And then if you're not signed in, we have like a model or something that says that you have to sign in. But to be able to achieve that, we have to allow like the feature to load up, like the feature controlling this stuff. And that feature will just be in like not authenticated state. So you would have something like, let's see, how would this work? Yeah, so the question is like, what about the in-between thing here? Like it actually needs to check if you're authenticated or not. Should it be able to show this while it's figuring out if you're authenticated? Or should it just show this if you're authenticated or not, like when it's actually resolved? And that's the tricky thing. Ideally, I want this to be shown even though we don't know if you're authenticated or not, because that ties into server-side rendering. That means we can just render this out. Sorry to like go, so like, does it really matter? But it's an interesting challenge. So the way I would do this is that, okay, let's just write up everything we have. And then we have, let's just call it the dashboard feature for now. Dashboard feature. And then we have like the dashboard UI. That's kind of the gist of it. And we can do, so we kind of get the full picture of the two approaches. Let's see, there we go. Okay, so we can do this, but now the challenge is that the storage, like when you're not authenticate, like it means that we have to pass the family ID to every piece of interface on the storage. Because there's no connection between these two. So our dashboard feature needs to be like the relay between authentication and the storage. The good thing is that means that the dashboard feature can render out the skeleton while it's waiting for the auth to change. And well, actually, sorry, we also have like an auth feature. Auth feature, to be perfectly precise here. Auth feature. So this is how we would do it. Okay, so in this case, we have an auth feature that doesn't really, it will always, like it will deal with the actual authentication, and then the dashboard feature will use the auth feature. And it will render out the skeleton, like it will be in like a, I don't know, I guess it can just stay in loading state. It stays in loading state as long as it's resolving. If it's resolving authentication or if it's loading data, it will be in the loading state. And the loading state is basically this skeleton, and it should have like some movement to indicate that something is happening. But then the dashboard feature, when it's authenticated and you actually want to load the data, you have to pass the family ID into the storage so that the storage understands where to grab the data from. Which is okay. That's perfectly okay. Yeah. And maybe that's really how, like, I just have to decide, like, what's the opinion of React State's application architecture on this? Is it that the environment effects shouldn't really know? But then we have this thing at Code Sandbox where we have the JVT and we kind of want to toggle it. Anyways, let's explore the other alternatives. So we have rather an auth effect and we have an auth feature. Like the thing that differentiates Code Sandbox, the Code Sandbox example from this, is that the Code Sandbox example works without the JVT. It's not like you have to have the JVT for the rest of the interface to work. It will still work, you're just not authenticated on the endpoint or the endpoints. While here, you have to have a family ID to even use the interface, which is why I'm kind of hung up on this. But anyway, so if we have like auth effect and then we have the auth feature, it means that we could have like a proper way to do this would be to, this would have to be like its own. Yeah, this is interesting because this would actually have to be its own components. You would have like a dashboard. Yeah, it seems that it like overcomplicates it. Yeah, wait, that's, oh, wait a minute. I remember how we talked about this. It was like, if you have an environment effect that requires state, you have basically two options. Either you can treat it as an environment effect, you have to make it a feature. Or you have to give it internal state. So what I mean by creating a feature is that you will now have, it's not like this, it's like this. You don't do that, but you have an auth feature and then you have a storage feature. And that storage feature would, oh, sorry. And that storage feature would actually use the auth feature. And then you would have to dispatch. No, wait, this doesn't make sense. Oh my god, I can't decide on this. What's the best approach? Yeah, no, this is not what we talked about. I'm making this up. No, I think I want to settle with what I talked about. Like, if you have to make a decision, like, do you just want to make your interface very explicit? Like, you have to, for every single part of the interface, you have to pass in explicitly what you need? Or do you want to give it internal state so that you can configure it and then you can simplify the rest of the interface? In this case, I think, yeah, going back to the Code Sandbox example, there we have a JVT. So the interface works with and without the JVT. So having an interface that lets you set that JVT internally makes more sense than setting the family ID here, because this interface doesn't work at all without the family ID. And we're also going to basically use this interface from within, well, multiple features will actually use it. The thing is, what happens is that every single feature we implement now depends on storage and the authentication. That's the thing. Like, it depends on the auth feature and the and you only want to consume, like, it complicates the features. Wow, this is really difficult. I'm surprised how difficult, and the reason it's so freaking difficult, and I think this is why we often do it. The reason it's so difficult is because we want something to work without being authenticated. That's what we're trying to achieve here. And so and that's why you typically have a spinner in apps, right? Because it's so much easier. Like, the app only runs when you're actually authenticated. If you're not authenticated, it shows something completely different. But in this case, we do want to show parts of the app like partially authenticated, or we partially want to show the app based on you being authenticated or not. And it just it increases the complexity a ton just for this simple skeleton. And I think, like, my theory is that people typically just drop it because it adds so much complexity. And not necessarily implementation complexity, but just like conceptual complexity. How do you think about it? How do you actually implement it and name things and separate the concerns and who consumes what and all that stuff? You have to think long and hard about that. Maybe I'm going at it the wrong way. There's probably a different way to attack this, but from this perspective, it's really, really tricky. And like, maybe I should just do some pseudocode for this. So if we have our dashboard feature, the thing is that this dashboard feature needs to know about the auth. Use auth, the auth feature. Like, we have to know what state we are in. So the way this would work is that we would have like, let's see, dashboard would be use reducer and the reducer, and then we would have an initial state there, which would be like loading. Now the thing is, what we would do, this is interesting, we haven't played around with this. What we would need to do is that we would need to actually exec on the auth. Yeah, this is interesting. Oh, this is very interesting. I haven't thought about it this way. So what we're doing here now, we're actually driving the state of our dashboard based on the state of our authentication. So we would also have like a use effect for, oh, sorry, so this will be a const context dispatch. This will be like the dashboard. Let's see. So this would be, now it's like loading, but we wouldn't, sorry about that. That's typical 4-year-old behavior. Let's see. So we wouldn't be in a loading state. Like it depends on authentication. Like, are we authenticated? Like we can't actually start loading anything. So we would have to have a state that indicates that we're not actually loading. We are like waiting authentication. That's what we're waiting for. Pending authentication. That's the initial state, and that would render the skeleton, right? So when we load up the dashboard, we will have pending authentication, and that renders the skeleton. But we would also render the skeleton when we are loading. So it's two different states, but the reason it's two different states is because, so let's say we move into authenticated on the auth, and that's when we actually dispatch to our dashboard, like load. So we ask it to start loading, and that moves the dashboard into a loading state. And here we do the loading, and so that's the thing. Like pending authentication doesn't drive a side effect. It's just waiting for this authentication to resolve itself. Yes. That's one way to think about it. We could also I like this concept of one feature driving the state of another feature. Because at the consumption level, like when you consume it from the actual dashboard component, you only care about the dashboard. You don't have to bring in the authentication and the dashboard, because you don't care about the authentication there. You just care about the dashboard itself. Yes. So we start in pending authentication. It renders the skeleton. We get authenticated, which triggers, like, it tells the dashboard to start loading. So you would have the storage here equals use environment, and that would start, like, here you would do storage get blah blah blah, and you would start resolving these things, but this skeleton would be there no matter if you're pending authentication or you're actually in a loading state. But we have the possibility to, like, indicate both things. Now the thing is, what if you're not authenticated? So it has pending authentication and it says unauthenticated. What do we do then? Like, now it's a little bit weird that we change the state of the dashboard. kind of, I don't know, like maybe it's not. Maybe it's not. So we could put it into like a no, sorry. So this like fetch, yeah, load. Let's just call it load. And when you're unauthenticated, we could say like no access, for example. So when we dispatch that, it moves to, let's just, oh, that's weird. So let's say it has pending authentication, it has a loading state, and it has a I am in, yeah. Yeah, we should actually dispatch, sorry. This is an event. So this, well, that's a tricky thing also. Like this model, like we're talking about actions, and actions sounds imperative, like fetch. But it's actually wrong. It shouldn't, oh. Like for in the world of state machines, it's not actions, it's events, right? It's something happened, and then you kind of dispatch that something happened, and then it's up to the machine to kind of figure out what to deal with that. When it's called an action, it's not really, it's imperative. It's like, do this. But that's not right. So in this case, you would just say authenticated, right? Because that's what happened. And here you would say unauthenticated, because that's what happened. And then in this case, the authenticated event would move you into a loading state, while the unauthenticated event would move you into a no access state. Should I change from actions to events? Because you don't like, typically in Redux you have like a fetch action, and then you have like fetch success and fetch error, right? But it's actually fetch requested. That's actually, it's not like, it's not go fetch, it's like a request for a fetch happen. But maybe I'm going too far with this, but I think it's easier to reason about how the application works when you think about it as events and not as actions, because that's really how it works. Like when you click a button, that's an event, it's not an action. Like the button was clicked, right? It might represent something, like it might represent signing in, like it's a sign-in button, but it's not like you click the button and you tell the application to sign in. What happened is that the user clicked the sign-in button. That's what happened. And then it's up to the application to decide what happens now. Where the action term kind of encourages the thinking of the user driving the application, while when it's event, it's named as an event, it encourages the thinking that user interactions are just things that happen. It's up to the application to figure out what to do with that. Yes, I think it fits the mental model way better than an action. It's just a leftover from Redux, like a reducer. So a reducer is, this is interesting. So a reducer is state and action. And what we're changing it to is context and event. That fits better. Okay, so I think I'm going to make that change, because it fits the mental model better. maybe we should, okay, sorry I'm jumping out of this because I really want to work on the application, but let's, oh, what happened here? Let's see how the Excalibur Firebase thing would work if we thought about events instead of, let's do something simple. So here we have auth action. So here we would say auth event. So this could be like, what happened? Well, we signed in, like, and sign in success and sign in error. Those are events, right? Those are actually named events. Something happened. We can also say like sign in happened. That's the tricky thing. It's like you can like well, a sign in did not happen. That's the thing. Like a fetch did not happen. That's imperative. You're telling it like it shouldn't be imperative. I guess like what I'm saying in these states here, like naming these states, they should be like I am authenticated, I am checking authentication, I am signing in, right? I am error. That's a little bit weird, right? But that doesn't matter. The important thing is that it's not imperative. That's the whole point. It shouldn't be, it's not what it should be, it's about what it shouldn't be. It shouldn't be imperative. So it shouldn't be sign in, I am sign in, I am fetch, right? It shouldn't be that. And I think if we apply the same rule for the events, we enforce the mental model of like the environment is not in control of driving this app. Meaning that if we have an auth action of sign in, the mental model becomes, okay, the user is now telling the application to sign in. But that's not what's happening. What's happening is that the user just happened to click the sign in button. That triggered an event. So it could even be like sign in button clicked. That is actually what happened, right? That's actually what happened. But you don't have to say that the button was clicked. You can be more generic. You can see sign in requested. Because that's what actually, like, that's actually what happens. And it enforces the idea that it's a request for something. It's not telling the app what to do. Because it is, at the end of the day, it is only a request. It might not actually do the sign in. Yeah, I really want to. So this ties into where do I have that Excalibur? Here we have it. I really want to enforce this idea. So your app is mounted into this environment, right? And in this case, it's the browser. And this environment is completely unpredictable. It's just a bunch of events happening, including user interactions, like a button click, a visibility change, an HTTP response, a URL change. Like these things can happen at any point in time. It's completely unpredictable, completely random. And your app is mounted in the center of this. It's being bombarded with these events. And the job of your app is to make this unpredictable environment into a predictable experience for the user. And that is what state machines does so well. You can just hammer events at them and they will always do the right thing because you're guarding, you're not making the events imperative, like they're not commands. The event is not saying what the app should do. It's just informing the app about the event occurring. And then it's up to the app to decide if this event should drive the application state forward. That's the whole point. And yeah, again, naming it event enforces that idea. If I start talking about these as actions, Like that would mean that, oh, when you click that button, then it's an action, so the state should change. But that's the whole problem. That's what we're doing wrong now. We're treating user interactions and all the other events as driving the state forward. And that's what's causing all the bugs. Okay. Let's change this. And yeah, so to conclude on like how we would actually deal with this is how I want to deal with it. This became more obvious now that we're talking about events, is that we can have a feature. So this is like an emerging pattern in the architecture, is that you can have a feature that that depends on another feature, and that other feature actually drives some of the state of this feature. So the dashboard actually has a state of pending authentication, it has loading, and it has no access. It has other states as well, but these are the ones we're talking about, where it starts in pending authentication, and then it's the authentication feature that drives the next step. So whenever it's authenticated or unauthenticated, that event will drive the next state, either going to loading or no access. When it goes to loading, it will start a transition effect, which starts grabbing the data, which will dispatch a successful event related to loading data, and it will move it into like a loaded state. That's really nice. And then what would happen again is like, okay, you might get an unauthenticated. Like if for some reason the auth moves to unauthenticated again, it will actually move the dashboard into a no access state again. And it will move back to the skeleton and showing the sign in button, which is really good. That's what we want. Yes. That's what we want. Okay, cool. I guess we won't get further on this. I think I'm going to refactor React states to be about events and update documentation for that. And then tomorrow we'll actually implement this way to explore this. And I really like this. You used to think about state as just a bunch of state values where you have an action that drives changes to that state. Now you have a context which can be in different states, and you just trigger events. And those events are like guarded. And yeah, maybe I should extend this a little bit. Like modeling, like the old way. Oh, I'm inspired. So modeling the state. That's one way. That's this part. Driving the state. How does that work? Yeah, I guess it's just those two. So this is about modeling the state. This is this part, and then this is how you drive the state. So in the old way, you model the state as just having a bunch of state values. They're not related to each other, they're just always there. And driving the state is an action directly changes the state. While in the new thing, you have a context that is in a specific state and with its related values. So you have multiple representations of the state with an explicit state property. And the way you drive the state is that you just tell it about an event occurring, and then the reducer decides how if that event is valid for the current state. That was a bad explanation, but there's something here. Reducer of state action. reducer of context event. Okay, anyways, I'll make this more clear the next time. I'll summarize it for you. And then we can actually get going with the application. This is what, yeah, but I think this is like I'm not doing this stream to build an application. Like that's not what the stream is about. Like you can build this application in a ton of different ways. It's not like the application itself that's the exciting part. It's really thinking about how you implement that application. That's what we're talking about here. Cool. I'll guess I'll see you tomorrow. I have to go. I'll update the documentation. We'll implement the way I talked about at the end to test that pattern, which can be added to the documentation as well. And then, yeah, cool. Thanks for following along, and we'll talk tomorrow.